How does SVM use hyperplanes for AI classification? Have you ever wondered how machines can learn to classify data? One powerful method is through support vector machines, or SVM. Let's break down how SVM uses hyperplanes for this task. At its core, SVM is a supervised machine learning algorithm designed for classification. The main goal of SVM is to find a hyperplane that best separates different classes in a dataset. Now, what is a hyperplane? Think of it as a decision boundary that divides the space into two sections, each representing a different class. In two-dimensional space, this hyperplane is simply a line. In higher dimensions, it becomes a plane or a more complex shape. SVM works by selecting the hyperplane that maximizes the margin. The margin is the distance between the hyperplane and the nearest data points from each class. These closest points are known as support vectors. They play a crucial role because they help define the position and orientation of the hyperplane. By maximizing this margin, SVM aims to improve its ability to classify new and seen data accurately. If the data is clean and well separated, SVM can find a hard margin hyperplane that perfectly divides the classes. However, real-world data is often messy and may overlap. To handle this, SVM introduces a soft margin. This allows for some misclassifications by using slack variables, which helps balance the trade-off between maximizing the margin and minimizing errors. For datasets that cannot be separated linearly, SVM employs kernel functions. These functions transform the original data into a higher dimensional space, where a linear hyperplane can effectively separate the classes. This approach is known as the kernel trick. Common kernel functions include linear, polynomial, radial basis function, and sigmoid. The choice of kernel depends on the specific characteristics of the data and the classification problem at hand. SVMs are widely used in various applications, including image recognition, text classification, and bioinformatics. They are particularly effective because they focus on the most important data points, the support vectors, and create clear decision boundaries. From an ethical standpoint, it is essential to apply SVMs carefully to avoid bias. This is especially important in sensitive areas like healthcare and hiring. Understanding how SVM uses hyperplanes for classification allows practitioners to design models that are transparent and interpretable. In essence, SVM utilizes hyperplanes as decision boundaries to separate classes by maximizing the margin between them. It relies on support vectors to define this boundary and employs kernel functions to manage complex data. This method strikes a balance between accuracy and generalization, making SVM a robust tool in supervised learning classification tasks.